Welcome to the session. 5 seconds to check out the code for this session. I wanted to have it up earlier for you. Sorry, had some technical difficulties. If you want to follow along to the code, head out here. If you want to follow along later, come see me after the show. We'll get you hooked up. Welcome to Callbacks, Events, and More. Bring Sanity to your asynchronous lightning code. This is the second session of this. If you hung out with me on Monday, you're going to be let down because it's the exact same stuff. But if we haven't met before, then it'll be all new to you. So that's awesome. I'm your host, Tom Petros. I'm the founder and CTO of Red Argyle. We're a Salesforce consulting and development shop founded in 2010. We work with companies large and small to solve business process, integration, and user experience challenges for the Salesforce platform. So here's what we're going to get through today. If you've worked on Lightning Components, you've come to the right place. If you're thinking about working on Lightning Components, you've come to the right place, but we're going to move super fast, so try to hold on. We're going to spend a lot of time talking about callbacks and events and how to deal with things like A.enqueueAction, trying to prevent writing callback hell pyramids in your code, and hopefully solving the existential crisis of what type of Lightning events you're supposed to use when. I have a personal preferences for that. We'll probably get into some philosophical conversations and hopefully no arguments or fistfights. So through this session, we'll talk about callbacks, what they are, how to use them a little bit more efficiently with what I'm going to call a proxy component by connecting your Apex and your Lightning code and never having to write that connection code again. We'll talk about events, what they are, how to use them. And we'll look at a lot of code through the whole session. And I'm going to use the term flatness quite a bit throughout this whole session because I look at flatness from a developer's perspective as how to not bury code inside of code, which is the whole essence of callback hell that we're trying to avoid. I also look at it as a way to develop as a team in a consistent, low-friction, repeatable way so that you and your teammates can understand what's going on. So the next guy that picks up your code knows what the heck you were talking about. One more shot with the code. Think fast, we're moving on. So what is a callback? Well, my simple definition of a callback is a function that you pass to another function that's going to get called later. You might include some parameters with that function, and the benefit of that callback is it remembers the context from which it was called. So all the variables that lived around that callback can be remembered by the callback itself and can be acted upon. The Aura Framework's A.enqueueAction method is really the number one callbacker inside of the Lightning framework. This is basically the glue that connects your Lightning to your Apex code. You're going to pass in an action parameter to this guy, which is going to be the whole set of stuff you want Apex to call and the method and the parameters, and it's going to give you stuff back, and Lightning's basically going to twiddle its thumbs until it hears back from the server. So let's take a quick look at a simple example and a crappier example of what callbacks might look like. And I am way over here. You guys can see that, right? Oh, that's super. It's like hyperspace. Okay, here we go. Here's an example of a simple callback in Apex. In Lightning. Now, we're not going to get into a lot of detail of rendering and what things look like. We're really going to talk about the guts of how these components work. So this is a simple component, just outputs basically an attribute that we set inside of our code. The controller here, not much going on. I don't put a lot of code in the controllers. I do client-side stuff in your controllers, do server-side stuff in your helpers. So this controller is just telling it to initialize and go do work. The helper method is where all the magic happens. So this is where we're going to make our call out to Apex, wait for our response, and then process that response. So this, if you've written a Lightning component that's talked to Apex, you've written this at least 1,000 times. We're going to go find the method that our Lightning component is connected to as far as an Apex controller goes. We're going to specify what that callback looks like, and then we're basically going to wait for response states to come back from the server. Now, I'm going to be super optimistic and just hope that this comes back successful. And I'm going to be super lazy and say if it errors out, I'm just going to blindly throw something to the console log and pretend like it never happened. I'm sure I'm the only developer that's ever done that. In this example, we're just going to wait for a response from the server and set an attribute. So don't worry too much about what the Apex is doing. Just know that there's data coming back, and we'll get our response there. So, and then finally, we call A.enqueueAction down here, and we're good. We got our data back from the server. This is great until it gets to be not so great. So let's look at an example of where I make a call to the server, I get a response back, and then based on that response, I got to make another call to the server, get a response back, et cetera, et cetera. We'll call this one callback hell. Controller again. not much going on in this Lightning component. We're just going to pass it down into our helper and begin our descent into callback hell. And we'll start the same process that we saw in our simple component. We're going to go declare the method that we want to call in Apex, get our callback ready, wait for the state, success or failure, something comes back. Let's be optimistic again and say it was successful. I'll set another attribute in my Lightning component, and then I'll go do the whole thing all over again. So now I'm going to call another method with the data that I just got back, set a callback, wait for a state, get a result, and sure, let's do it again. We'll call a third method inside of here. So this can just keep going methods all the way down. Turn your head sideways, kind of looks like a pyramid from the top down. This is terrible. We don't want to do this. This is like not legible. It's hard to follow. I don't know if I'm in response 2, 3, 4, 5, depending on how deep I've gotten. We want to avoid this. So how exactly do we avoid this? So those enqueueAction calls start to pile up, but in the end, they all do the same thing over and over again. They call an Apex method with parameters, handle success or failure, and do something with the outcome. So we could probably package that all up and maybe never have to write that code again. So let's see how we could do that. I'm going to introduce the concept of a proxy component to you, whose purpose is not to actually render or do anything on the client side, but really just to sit there and handle all of your server-side calls so you don't have to worry about them anymore. So let's take a look at that. Got another component here called Apex Proxy. Now, Apex Proxy doesn't have any markup that it outputs. We're just declaring a few things inside of this component. Namely, to start, you can ignore the events at the top. We'll come back to that. But the aura method that's here, called call, is a method that can be exposed from this component to a component that consumes it. So the call method here takes all of those parameters that we have to throw in and out of our action callbacks for enqueueAction, bundles them all up, and can accept them dynamically from any component that consumes the Apex Proxy component. I'm going to pass it a method. I'm going to pass it some parameters. I'm going to pass it either a function to call when it's successful or fails, or I'm going to pass, when we talk about events in a second, I'm going to pass it a name or a title or a label that a component or application-based event could listen for when this job is done. The controller here, again, doesn't do much. It just exposes that call method, again, to a calling component to issue that call. And then the helper, one more time, for hopefully the last time, if we look from line 15 down, it's the same code we've looked at here before where we're going to enqueueAction. But up above that, those are all the parameters that I'll pass into my call that get passed now dynamically into my Apex call and my callback. So hypothetically, I don't ever have to write that code again. Let's see what this looks like when a component is consuming it. If I can find my cursor on the screen. Hey, there you are. All right. So here's an example of a component that consumes Apex Proxy. And Apex Proxy is right here in the page, or in the component. We've given it a name because we're going to go find this component in a second in our controller to say, hey, I'd like to call your call function. I know it's a terrible name for a method, but you get the idea. Again, we're just going to populate some attributes just for argument's sake. But the goal here is to avoid this real-world scenario of, all right, I'm going to make an account, and then I'm going to make a contact, and then I'm going to make an opportunity, and then I'm going to make this and make that. So we don't have to keep bundling all that in. We can just keep calling back to our Apex proxy. The controller in this consuming component, not doing much, just initializing itself. The helper is where we actually do work with our Apex proxy. So here in the helper of this component, the first thing it's going to go do is find that Apex proxy component whose method I want to call. That's how we do that there. Then we still have an Apex controller attached to this parent component. And those are the methods that we ultimately want to call. So I'm going to say this is the action I want to call. That's still similar. Can't get away from that. I'm going to create a data structure here for the parameters I want to pass into my Apex method. This object is going to be case aware. So if you pass it a number, or if your method expects a number as a parameter, make sure it's numeric. If it wants a string, make sure it's a string. If it's a Boolean, you get the idea. Just make your data types match up. And then I'm going to call that call method from Apex proxy. So this is where we've bundled up all of our call out and callback logic. I pass in the action, the parameters. I'm passing two functions here now. So when this is successful, it's going to call this first function, the success function. Because the callback remembers its context, I still have access to component and event and helper that started this whole thing, so I can take action on the component that used Apex Proxy to make its call out. This is great. I tried this when I first started building this thing. I tried passing in the component of the caller and passing the event back, and it was just terrible. Like there was a shell of a component that came out of that whole process. So that was a bad idea. Knowing that you can just maintain context in a callback like this made it super easy and didn't have to try to thread the needle with all that stuff. So I've got a success function here. I've got an error function here. There's one more parameter that we can pass to Apex Proxy, but we'll talk about that in a second when we talk about events. If I go back over to Apex Proxy real quick, we can see where these calls actually happen. So in our previous examples where we were evaluating the state that came back from the server, success or failure, instead of just doing stuff there because we hard-coded this boilerplate stuff in all of our components, now I can evaluate a little bit and say, what did you pass into Apex Proxy to call when it was successful? If you passed me a function, I'll go ahead and call that function and throw the data back that came from the server to it. So now I'm back up at the parent component that consumed this thing, and everything's back. I'm back to working at my component. Apex Proxy's done with its work. Same thing with an error down below. Pass me a function, I'll yell and call your error function. We'll take a look at these application and component examples here in a second. So, quick recap on callbacks. It's how Lightning and Apex talk to one another. Everything's going through enqueueAction. That's the highway between your client and your server side. It's easy to get stuff deeply nested. Find yourself in callback hell and forget what context you have. It's just kind of nasty to look at too. So, if we can find a pattern, make a proxy, and build up those reusable functions inside of our Apex proxy in this example, and surely you'll find some other examples to do loading and saving and making searching lists and things like that. You could build proxies for everything to really help you flatten out your code to the point that you have very little server-side logic happening in your components. You can just lean on other components to serve in that role. So let's talk a little bit about events in 7 minutes or less. So events in Lightning are really the way that components talk to each other. So we've used this callback and Apex proxy example to understand how the client talks to the server. Now how do we get our components talking to one another? There's two flavors of events in Lightning. We've got component events and we've got application events. And I think of them in very simple terms where component events talk in the family tree. So if I've got a component that has a child and a grandchild, etc., they can talk amongst themselves, talk across the kitchen table, if you will. And then you've got application events, which can talk much more broadly, talk across the entire application. The application events are great for creating sort of a publish and subscribe model within your components, because I can have component A over here, who's oblivious of component B over here, but knows that an event exists in the system such that component A can say, hey, here's some important data. Component B can wait and listen for that. The only downside of application events is they're super broad, right? So anything that's listening for those events coming from one component can hear it and do something with it. And it can get easy to, have this component talk to that one, talk to this one, talk to that one, and kind of get off the guardrails a little bit. So you got to be a little bit more careful with application events, but component events are, on the flip side, a little bit more isolating and can't kind of break out of the family tree. So let's take a look at a couple of examples of application and component events in the context of our Apex proxy. So when we looked at Apex proxy a few minutes ago, we were passing in functions to have it handle the success or failure that comes back from the server. Now, let's have Apex proxy broadcast application and component events so we can get even a little bit more flexibility out of our Apex proxy component, such that maybe one component calls it and another component's waiting to listen, but it doesn't need to know where that source call came from. So an event in Lightning looks a lot like this. It's really just a definition or a fingerprint, if you will, of what kind of data do you want to have broadcast when this event is fired. In the case of Apex Proxy, we created an application event and a component event, very generic. I tend to build my events very generically and just insert sort of a label or a string or a title or something, so you don't end up with dozens or hundreds of very specifically named events inside of your application. For me, it's a matter of style. If you prefer those really specifically named events, go for it. I like to keep them kind of generic because I can reuse them. Further keep this generic, the data that's passed is just a generic object. That could be whatever comes back from the server. The event doesn't care. Just take whatever data and run with it. And then discretely, if there's an error, sometimes that looks just fundamentally different when it comes back from the server. So we pass that as a separate object. It also makes it easier for a listener of this or a handler of this event to be able to evaluate quickly, like, is your data null? Yes. Okay, maybe there's an error. Is your error null? Yes. All right, I'm going to do something with it. I don't know what, but at least I'll understand that there's good versus bad that comes back from these events. Let's take a look at what what firing the application event looks like from another example component. So here's an example component that is handling an application event that fires from the Apex proxy. So I've got Apex proxy here again declared, and then I've got a handler for that global Apex proxy application event. And within this, there's a method that's going to sit and wait and handle whatever Apex proxy has to broadcast and go do something with that. Just a contrived example, but there's the code. We're just going to set an attribute. You'd probably do something more useful inside of your code. From a helper perspective, this is a much more concise example of a component summoning or finding and then calling Apex proxy with the parameters we talked about before. The only addition here and slight change, at the bottom of the component list, I'm passing a flag that says call your application event, and that's what that Apex proxy application event is. So that's the flag we use there. And then the two parameters before that, those were the functions for success and error in the past. I'm just passing in these labels so that they can come in through my application event and be stamped as the title on those. So anybody that's listening can evaluate and say, oh, this thing passed me method 3 success, I should do something with that. Or if it's listening for method 4 success, it's not going to do anything because this label, it's not the label it's looking for. And then over in the Apex proxy, we can see where this gets handled. So here again in our success on the callback, we talked about calling the function previously here. Now we can evaluate and say, if what you passed me was a string, I'm going to treat that as the label for the event that came through. And then that last parameter where we talked about application versus component, that's what we call event level here. It's just looking to see, like, did you tell me to fire the application event? If so, I'll wire myself up and fire that event so the whole world can see it. Or on the flip side, if you pass me a component level event, I'm still going to fire an event. It looks exactly the same. It's just the scope in which that can be heard by other components changes. If we take a quick look at the component event here, same exact footprint. We're passing the same data. It's just a different grade. Quite frankly, I think the only reason we needed two events here was because you have to declare the type of one, component versus application, so you can't have one event to rule them all. But if you look at the example here, very similar. We're still summoning Apex proxy. The difference here is when we do a component level event, we actually need to pass that into Apex proxy on behalf of the containing component. So I've still got a method on this component's controller as to how to handle this, but the syntax is just slightly different where we have an onComplete event that the Apex proxy listens for, and we pass that in slightly differently. The nuance is a global application event, I would have a tag for that to listen for it and handle it separately. Then from there, the code is effectively the same. Oh, sorry. Our example is here. There we go. Our handler summons Apex proxy, finds that action, does all the same stuff. We're just passing component as the event here. So that's the whirlwind tour of handling events inside of that Apex proxy. So to recap, I think events really help promote flatness because they abstract our components away from one another. A component doesn't need to know that another component exists. It just needs to shout, and hopefully the component that wants to consume whatever event's being handled is there to listen. And then we talked at length about component and application events. I think component events are a little bit more local, live in the silo of your component architecture. Application events can talk broadly and globally across your entire application for any component that wants to listen. Great for sort of a publish-subscribe model, but with great power comes great responsibility. And finally, In my experience building this and also just doing about a year's worth of Lightning development, I've come to understand that there is a Lightning way of doing things, and callbacks and events in Lightning have much less friction than trying to pass and maintain state of component objects that live inside of your controllers and helpers. You just let those events and callbacks talk to one another. It's going to be much smoother, much easier. You just have to kind of rewire some of the way that you've maybe thought about components in the past. The red light is blinking. I'm apparently out of time, but I would love to talk to whoever wants to talk nerdy over on the side of the stage. Yes, there we go. Thank you, everybody, for coming.